Layer on one at a time, so you can't turn on more than one at a time. So for the matrix one, whenever it's falling, it's flickering because we're actually turning on 3 different layers really quickly. So we'll be like, alright, this one, and this one, and this one, right, like below it, and then so as it's dropping, it looks like it's actually. That's why I see how it's like kind of flickering. Yeah. But with my new design, I went ahead and got rid of the decoder, and we actually use 16 separate pins, and now I'll be able to turn on 16 at one time. So we'll be able to turn on the time hopefully that helps out. But it consumes very little power. It only consumes about 400 milliamps, which an entire no.
Okay. So this is MirrorMate.
Alright.
And the idea of MirrorMate is to be a driver aid that will keep your eyes on the road as much as possible. Or, I mean, you do look at the mirror, but you're still able to keep your eyes on the road. What this does is it detects emergency vehicles via the Opticom system. I'm not sure if you're familiar with what that is.
No.
What the Opticom system is fire trucks and ambulances have an infrared beacon mounted on their roof that will trigger the stoplights to turn green.
Okay.
So I'm sure you've probably heard of that.
Yeah.
This will detect that signal and will say, hey, there's a fire truck behind you or something, right?
Well, I mean, it's definitely a fire truck. It could be any vehicle.
It could be any emergency vehicle. Okay. You have this beacon, which is also infrared, and this can be placed into construction zones, school zones, pretty much any place that a driving hazard might exist or you may want to slow down.
Okay.
So, and again, this is an infrared beacon, just like the Opticom.
What does it indicate again? Sorry.
School zones, construction zones, accident scenes, or maybe special events.
Okay.
And it actually encodes zone type and speed limit information into the signal, which is interpreted by the mirror.
Okay.
And additionally, there is a smartphone app, which you can get navigation directions. Okay, so we're at 0 and 5. It's a school zone, and this is configurable. So we're at a school zone at 10 miles an hour. So if you look over here, we've actually received that signal and it's saying you're in a school zone. You just slow down at 10 miles per hour.
Oh, is that what it's indicating over here?
And it is directional. However, since we're inside and this beacon is pretty powerful, it's picking it up from all directions. So that's cool. But the directions do work.
So if that was to change to a different zone
right now, we'll change it to a little bit faster. See, it picked it up, and now we're at 25.
Okay. Oh, so then it just indicates your school zone.
Yep. So we'll continue to a construction zone as well. So let's go to the construction zone, and we'll make it a little bit faster. This will actually save the information, so it'll take it just a second.
So you said this is doing this all wirelessly, or?
Yeah, this is all wireless. Yep. If you actually point your phone at this, you can see it transmitting. See how the lights are on? You can't see that.
That's cool. Very cool, man.
And the infrared receiver is located in this module right down here. We'll find some place that we want to go. Drop a pin. Yes, we want to go there. Then we get directions. So now we have a list. So we hit next direction. And in just a second, it will update on the screen. So it says continue west. We were a little bit limited with the LCD on how much information we could put on the LCD. So the directions are fairly simple. But I think for a proof of concept, we showed that this is something that is very feasible and that could be done. You could display full directions on the screen. So I'll hit next direction again. And we're going to turn right onto Gemini. Give it just a second, it'll update. And you see we are receiving both Bluetooth directions and speed zone information at the same time. So,
and is that active temperature, or?
That is active temperature, yes. And the compass works as well.
Runs out this cable and you can put it through the header in your car to the front bumper.
Do you have to push the next direction button
I'm sorry, what's that?
Do you have to push the next direction button to get it here?
Yes.
Okay, so I guess at this
Doesn't
point,
it do automatically?
He's better explaining it than I am, but the Google Maps API, there's actually a legal issue with doing a turn-by-turn navigation software with their API because we were utilizing the Google Maps API. Okay. So we had to do it this way because for legal reasons. So,
but it's doable.
Yeah. That's awesome.
So you end on.
Very cool.
What's up, dude?
So how does this work, man? Like how y'all?
We're using EEG signals from the brain.
You use image like signals from the brain to do that?
Because the headset reads our EEG signals.
Okay.
Because we're using 14 different sensors, depending on the areas, because each of the sensors are mapped to different areas of the brain.
Really?
Depending on which areas of the brain are activated. Because each thought pattern, depending on the thought pattern, it activates different areas of the brain.
Yeah.
So we're just using the signals, the areas activated in the brain. The signals to process it through our motherboard and our programming, and we translate the signal and send it directly to the motor controller.
So because this is kind of like amazing. So like, I don't know, did y'all like you bought the headset separately or? Okay, and then you just map whatever is coming from there to
We have
that.
to train the headset to understand
Okay.
what he's thinking.
Okay.
So it's like parts of it.
Basically, I just think no, it's really tactics.
So if I put out my head, I can use it. Anybody can use it.
Anybody can use it, but it takes a while for it to
Okay, so I have to train further.
Yeah, you have to
To
train
talk backwards, I think in Swedish
because everybody has different
because it activates a different area of the
He's
brain.
thinking about
So you're activating
Swedish
true
and
motor
stuff like
cortex.
that, and that he had it trained for that to correspond to a command of moving back.
Yeah, I mean, there's other people that
Oh, explain that again. You think it's what do you mean? You think it's Swedish?
He's thinking about the Swedish language because that's how he trained himself for it to recognize that he's thinking about changing.
Oh wow. Okay.
depends on how much voltage you want. The principle will act for anything. We can put, I think, 12 volts through this chip, which is controlling everything. So basically, if we wanted to up the motors more, we could. We just figured you could
teach a paraplegic how to do basic movement.
Yeah, another put it in a wheelchair would be probably the most practical application for it. But we wanted to combine it with our tailgate things. Just mind control your tailgate around you. But yeah, you can really apply it to anything with wheels.
Interesting. Alright. Well, I was going to say, I like the way your brain works. He's over there too, and he works.
Well, it's not really paying anymore. And it wasn't really in the frame, it was just a light frame.
Good luck.
Usually you can have a say
in it now, but I was like, why not?
See if it works. Just don't know what to pick up one. That's a little better.
So here we have our microcontroller. It's a Stars Launchpad. Underneath we have a gyroscope accelerometer. And here we have our infrared LED and touch capacitive buttons. We have a left click, can detect both right and left click, release and click, and then our right click also release and click. And we have here our camera module with IR sensor there. So it sends a pulse width modulation to detect the clicks, and it's all via Bluetooth here. And and we're using the MSP430 on the camera modules to do that. So here, as I move the LED around on the glove, it maps the mouse across the screen. And we have specific gestures that go on. So we have multimedia gestures here in Windows Media Player. Make that the active window here real quick, and we'll go ahead and play. So we're playing the video here. We'll go full screen here, right there. Let's go ahead and pause the movie. So pause the movie there. Do a rewind, because we're close to the end. Stop the rewind. And we'll go ahead and play the movie again. And let's go ahead and get out of full screen mode there. I'll pause the movie one more time and do a quick fast forward. Let's try again. Fast forward. There we go. Fast forward through the movie. And then stop it. And then we also have gestures for... Lost the image right here. There it is. Okay, and we also have gestures for our browser control here. So we have a refresh gesture. And do a refresh. Refresh the screen again. There you go, you can see it changing. That's our refresh gesture there. And then of course we can do a print screen real quick. So those are the gestures that we have on our media.
The mean queen, so it shows me that I can kill any three of those because it's what I've read. So I don't know, let's take this piece. Is that a problem? There's a couple squares on the board that are having issues letting the infrared light all the way through. So you pick that up, it goes through an initial scan, set it back down, and light should turn on.
Okay.
Definitely a lot smaller.
Yeah. Is it working with the phone or?
What's that?
I know you guys have your phone over. I don't know.
My phone just rested there for a wait.
Yeah, it's just sitting.
Oh, okay. So what are the lights indicating? So I kind of
any open space it can move to.
Okay.
And red is any kill it can make. So if you take this piece off, it'll scan through and double check to see if you either put this piece back down in a new space or lifted another piece that you're going to take. So it should have gotten that one, place that, lights will go off, and now you know it's the other turn. It just basically, any piece you pick up, it'll show you, alright, these are all the moves you can make. And then it just keeps track of everything in software, so if you can keep playing, and then you'll get everything up to you.
Wow.
And this one should have green, and then red here, so you can jump to the side or kill.
So I guess it's our RGB LEDs then that you guys have.
Yep.
Yeah.
Hopefully. It's not dragging you.
We'll see. It is today, it just wants to.
Okay, I think we got it back.
Yay! Go ahead,
So it's a computer on the other side then?
I think it's comparing both.
Dude,
I know, right?
if you put all that in front of this, get yourself in a casing, you know how sick that would be? You just see the pieces move? I'm marking the crap out of that. What? I did change the pulse on it. You see that thing just smash. Where did he get that?
So the computer thing
awesome.
No, I haven't had any. I'm at the Senior Design Fair right now, but I'm just around. Yeah, I'm just chilling and visiting. It's over at the Harrison building. Okay. Sounds fantastic. Alright, we'll be back in a little bit.
Alright. Alright.
Have one, each three.
Wow. That's pretty good. That's impressive.
Move out of the way. I've seen it many times.
Is it playing itself right now?
Yeah. This is an actual guitar without any effects.
But it wasn't being really powerful.
Yeah, wait, when the ball goes around, $40 off Craigslist.
Oh, that's awesome.
Yep.
I guess I want it.
Yeah, exactly. So we just did some smart shopping.
Yeah, it's
Most of the money went into our charity.
Why do you use
All of the basically our printed circuit board. We designed an embedded processor just for this.
On this side,
So we have we're using a microcontroller, essentially an Arduino. If you're familiar with microcontrollers, so it's an Arduino and a motor driver put together all on the same board.
So what was the budget on it?
What was the what? Oh, budget is $1,000. 500 of it was sponsored, and the other 500 is that I pocket.
You got the sponsorship from that company that was doing AI.
Yeah, Sortec.
Wow. Did they sponsor an area?
They did one other group, one of the chess boards. I think there's 2 or 3 of them. Magic chess.
Oh, that one is really easy.
Yeah, they're the other Sortec text.
That one is really good.
Yeah, it looks so awesome. I was over there just going like, your mechanics look so legit.
I know.
That's
the crazy part is like how much it is mechanical. Like, you know, again, being electrical. So wait, what is this? Was it power or something?
Emergency stop. It is power. Like both of these, like if you hit either one of these, it'll shut the power off to the board.
Oh, okay. Patrick and I, we wrote it. I kicked out the class. Is that an expo? Oh,
yeah,
wow.
Connect.
And you're really a pro. Yeah, so just the Xbox Connect is all we use to gather the depth sensor. So you guys inspired by the beer pong table?
Yeah, was that like any? Nobody did that this year.
What? Oh,
The beer pong table.
Was that last year?
Yeah, I remember that.
That's pretty cool. Look at that. So what was your language you guys did it in? So we have an embedded processor running on each of the rods, and that's our C. Then we use C# for the AI and the